a map of the web. This is the blue lines are sort of the major trunk lines of information. And what I want to do is I'm suggesting, in fact, that this thing that we're connecting to is, in fact, the largest machine that we have made. That this thing that we're connecting to, the telephone company and the web, is in fact one machine. And I'm trying to suggest, in fact, that while we think of it as the web, and maybe we think of it as this little machine here and your cell phone there, that in fact these are all connected together and that they form one large machine. So there are several interesting things about this machine. First of all, it's the most reliable machine that we have ever made. In the approximately 30 years since the internet has begun from the phone system, it's never been down. It's never crashed entirely. So there's no other machine that we've made that has run for 30 years without ever stopping. So it's the most reliable machine that we have made. The second thing is I'm trying to give some idea of if this is one big machine, what are the dimensions of this machine? How big is it? What size of it? How fast does this machine run? So I've been investigating and performing calculations to determine how big it is, how fast it runs, how many transistors it has, what the bandwidth is, and I've come up with some figures. So think of this as one global machine. The dimensions of this are very interesting. There are about 100 billion clicks on the web every day. There's 100 billion clicks on this machine as a global machine. There are, inside the web, 55 trillion links. 55, 10 to the 15th links. So I determined that by finding out the number of web pages, which there are about 900 billion web pages on the web, and there's 62 links per page. And this gives us about 55 trillion links. Now what's really interesting about this is that there are in our brains about 55 trillion synapses to the rough magnitude. It's about 100, between 10 and 100 trillion synapses in our brain. And we have in this machine, the total machine, about 1 quintillion, that's 1 billion billion, 1 to the 10 to the 18, 1 quintillion transistors. So if we take all the transistors in this machine, and which are about 1 billion, and all the transistors in all the machines around the world, we get about 1 billion billion, 1 quintillion transistors in this large machine. That also happens to be about as many neurons as there are in a human brain. Okay? Just coincidentally, it turns out that this machine is the number of times that the clicks are happening per time. It turns out that there's about 20 petahertz. It runs in very, very fast. That's how fast these things are happening. And this machine, if you add up all the storage units, all the hard disks in the world, it comes up to 255 exabytes. This is exabyte is after you have a gigabyte, a terabyte, a petabyte, and then an exabyte. It's an incredibly large number. Okay? To give you some, I mean, you can't even comprehend how big that is. So this machine has an incredible memory. And then I just performed some other calculations showing the number of emails per second. There's 2 million emails sent every second. on the internet, on this global machine. There's 1 million internet instant messaging per second. And there's 8 terabytes of traffic per second zipping around the world. A terabyte is about the size, 8 terabytes is about the size of the Library of Congress in the U.S. That amount of information is just flicking around the entire internet every second. 65 billion phone calls, 1 million voice queries. This is a very, very large machine. And if I was just specking it out, trying to pretend that this was going to be sold on Amazon, just giving you some senses as again, if this was a machine that you had to buy, what it would be. Again, there it is. And here's another specification, which giving you in kind of just a few numbers: 170 quadrillion transistors, 55 trillion links, 10 megahertz, text email running at 31 kilohertz. Search, the number of searches per second, it's around 14 kilohertz from all over the world. This is just giving you a global view of this machine that we're making. And I want to, again, suggest that the way in which the web links are connected are exactly the same way that the neurons in your brain are connected. And so my suggestion is that this machine that we've made has already reached the same complexity and computational power as a human brain. Okay? The problem is that your brain is not doubling in power every 2 years, and this machine is. Okay? So, where we're headed with this is that this machine is now what I would call 1 HB, 1 human brain equivalent. If you are doubling every year or so, this machine will reach the equivalent of 6 billion human brains, which is how many human brains are on the earth right now. That's how many humans there are, in about 30 years from now. Which means that, in fact, that by, say, 2040, the web will exceed humanity in total processing power. Now, that's just to give you, again, some sense of what this machine is. So, it's gigantic. It's rapidly increasing in power. It's rapidly increasing in complexity as we program it to do new things. And I think there's going to be about I have suggestions of 4 dimensions that I believe that this will continue to expand in. And I want to review those 4 dimensions just to give you some idea of what I think is going to happen in not the next 30 years, perhaps maybe in the next 10 to 15 years. First of all, we're going to expand the ways in which we can interface and talk to this machine. Secondly, this machine is going to increase structuring of knowledge, which is the historical path of science and technology. That's what science and technology primarily do, is that they structure information. The third thing that this machine is happening is that we're giving it senses. We're giving it a body, basically. It's kind of a brain, and we're giving it a body. And the fourth thing is that we're becoming incredibly dependent on this machine. Our lives and our culture are becoming more and more dependent on it. So, the first idea of expanding interfaces. We see our pockets are full of these gadgets and machines on our desks and in our homes. And we think of them as all separate kind of things. The iPod and the iPhone and the cell phone and our big screen for the TV. We think of them as all different media. But in fact, all these things are different windows into the same machine. I kind of